निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Welcome back, students. In this session, we will study Chapter 2, Polynomials. The introduction part of exercise 1.3, that is division algorithm for polynomials. In order to understand the division algorithm for polynomials, let us divide a polynomial by another polynomial. The division of a polynomial by a polynomial was also there in class 9. Here we will be just revising and we will be moving those division part into our topic of division algorithm for polynomials in class 10. Let us take an example from the NCERT textbook. This is example number 7. Divide 3x cubed plus x squared plus 2x plus 5 by 1 plus 2x plus x squared. That means we have to divide this polynomial by this polynomial. In order to divide this polynomial by this polynomial, we have to look at the polynomials first, whether the polynomials are in the decreasing power of x or not. If they are not in the decreasing power of x, we will have to arrange them first in decreasing power of x. So this would have been written by divide 3x cubed plus x squared plus 2x plus 5. This is in the decreasing power of x. But this was not in the decreasing power of x. Here the degree of x is 0, the degree of x is 1, the degree of x is 2. It should have been the degree of x 2, 1 and 2 for the decreasing power of x. So this would have been written as x squared plus 2x plus 1. And now we will be dividing 3x cubed plus x squared plus 2x plus 1 by x squared plus 2x plus 1. So let us divide it. This is 3x squared x cubed plus x squared plus 2x plus 5 by x squared plus 2x plus 1. While performing the division of a polynomial by a polynomial, concentrate on the first term of the polynomial that is to be divided and the polynomial that is divided. Here the first term is 3x cubed and here the first term is x squared. Divide 3x cubed by x squared. Let us do some work, rough work here so that you can understand very well. And that value will give me the first term of my quotient. So divide 3x cubed by x squared, and this gives me 3x. So this 3x is the first term of my quotient. So we will write 3x into x squared is 3x cubed, and this first term should be multiplied with each term of the divisor. So 3x into x squared is 3x cubed that we have written. Then 3x plus 2x is plus 6x squared. So this is plus 6x squared. Then 3x into plus 1 is plus 3x. Then subtracting this all from the above one, you will have to change the signs. Plus become minus, plus become minus, and plus also becomes minus, and subtract. This cancels. 3x cubed minus 3x cubed cancels. Then plus x squared minus 6x squared will give minus 5x squared. Plus 2x and minus 3x will give me minus x plus 1. Now also the degree of x is 2 and the degree of x is 2. So the division will be continued. Till when it will be continued? When the degree of the remainder is less than the degree of the divisor, then our division stops. But presently we will be continuing. Again, concentrate on the first term here. and the first term here. Divide this by the first term of this. So next term that we'll be getting for the quotient is minus 5x square from the first term of here divided by x square from the first term of the divisor. This is x square and you get as minus 5, and that minus 5, this minus 5 is my next term for quotient. So here this will be minus 5. This minus 5 is again to be multiplied by each term of the divisor. That is right. Minus 5 into x square is minus 5x square. Then minus 5 into plus 2x is minus 10x, and minus 5 into plus 1 is minus 1. Subtracting, all the sign changes, and this minus 5x square plus 5x square becomes 0. Then minus x plus 10x is 9x, and plus 5 plus 5 is plus 1. Now, the degree of x is 1, and this degree of x is less than the degree of the divisor that we are using, x square plus 2x plus 1. That means when the degree of the variable in the remainder is less than the degree of the variable in the divisor, our division is completed. We cannot divide further. Now, this is how we divide a polynomial by a polynomial. How to compare this to get into our division algorithm for polynomials? Let us move on to another example, a simple division that we had gone through. Suppose we divide 25 divided by 4. So when we were dividing 25 by 4, this was 24, 6 subtracted 1. We used to consider that was to be divided to be our dividend, by which we have to divide was our divisor. The answer that we used to get is considered to be our quotient. And this was our remainder. The same concept is used there also. Here, the polynomial that is to be divided, this is considered to be my dividend, and it is always denoted by, say, p of x. The polynomial that divides the dividend, that is what we are calling it as a divisor. This is our divisor, given by the name, say, g of x. The answer that we used to get here was our quotient, so here also the answer that we are getting is considered to be our quotient, given by the polynomial, say, q of x, and the remainder that was left out at the end of the division process. Here also, this is considered to be the remainder, say, given by r of x. Now we have assigned all those things that has been normally taken in a simple division to a division in a polynomial. So this is my dividend, this is my divisor, this is my quotient, and this is my remainder. The dividend is denoted by p of x, the divisor is denoted by g of x, the quotient is denoted by q of x, and the remainder is denoted by r of x. Now, we know a simple division rule. We have studied in the previous chapter, also in chapter 1, that dividend is equals to divisor into quotient plus remainder. Here also the same thing follows, but here we would be expressing the dividend, divisor, quotient, remainder in terms of polynomials. Here dividend, we had denoted the dividend as p of x. So this is my p of x. The polynomial that divided the dividend p of x, that was given as g of x. Our divisor was g of x. So in place of divisor, we would be writing g of x. into our quotient that we have got is denoted by q of x. So we will be writing it as q of x, and plus the remainder that we had is denoted by another polynomial, say r of x. Now this we have got a relationship between a dividend, divisor, quotient and remainder as dividend polynomial p of x is equals to divisor polynomial g of x into quotient polynomial q of x and remainder polynomial r of x, that is p of x is equals to g of x into q of x plus r of x. This relationship is considered to be the division algorithm for polynomials. From now onwards, we won't be writing directly. We will have to mention which one is dividend, that is which one is p of x, which one is g of x, which one is q of x, and where is r of x. From now onwards, we will be giving name to the polynomials as p of x, g of x, q of x, r of x, and this is to be verified also if asked in the question to verify the division algorithm, then we will have to move on through this. So dividend is equals to divisor into quotient plus remainder, p of x is equals to g of x into q of x plus r of x is the division algorithm for polynomials. Number 8. Divide 3x squared minus x cubed minus 3x plus 5 by x minus 1 minus x squared and verify the division algorithm. That means we will have to divide a polynomial by another polynomial, and we will also have to verify the division algorithm. As I have told you in the previous examination, now would be denoting the names for the polynomials. And moreover, before continuing any division, I have told you earlier also that the degree of the variable should be in decreasing order. So let us arrange it and name it also. We have to divide this polynomial. So this is my p of x, and arranging it in the decreasing order of power of x is to the first degree 3. So this is minus x cubed plus 3x squared, then minus 3x and plus 5. We have assigned the name to the polynomial as well as we have arranged the decreasing power of the variable. Now we will have to divide by x minus 1 minus x squared. So let us assign the name of also here. This is gx, and that is also equals to, we will also have to arrange in the decreasing power of it. First degree 2, so this is minus x squared, then degree 1, so this is plus x, and then degree 0, so this is minus 1. So now we have assigned a name to the polynomials, and we have also arranged them in the decreasing power of x, and now we will be dividing it to obtain the quotient q of x and remainder r of x, and then we will be moving on to verify the division algorithm. So first of all, let us divide p of x by g of x. Minus x cubed plus 3x squared minus 3x plus 5, and we will have to divide this polynomial by minus x squared plus x minus 1. In the division process, I have told you that we will have to give more concentration on the first term. This is minus x squared of the dividend, and the first term minus x squared of the divisor. So let us find our first term in the quotient part, dividing minus x cubed by minus x squared. So minus x cubed divided by minus x squared, and this is equal to x. So the very first term that we are getting is x in our quotient. So let us see x, and this term is to be multiplied to each term of the divisor. So x into minus x squared is minus x cubed, then x into plus x is plus x squared, and x into minus 1 is minus x. Subtracting, we get minus x cubed plus x cubed is equals to 0, plus 3x squared minus x squared is 2x squared, minus 3x plus x is minus 2x plus 5. Again, we will have to concentrate on the first term, 2x squared minus x squared the degree is same, so the division will be continued. So we will have to divide 2x square by minus x square in order to get the next term for the quotient. So this is 2x square divided by minus x square, and this is minus 2. So this is our next term for the quotient. So this is minus 2. This minus 2 should be multiplied to each term of the divisor. So minus 2 into minus x square is 2x square, and minus 2 into plus x is minus 2x, and minus 2 into minus 1 is plus. Subtracting, we will have to change the signs, and plus 2x square minus 2x square cancels, minus 2x plus 2x is also cancels, and the remainder is 5 minus 2 is 6. So we have now got q of x as x minus 2 and r of x as 3. Now the division process is complete because the remainder is 3 whose degree of the variable is 0 and that degree is less than the degree of the divisor. Now we will have to verify the division algorithm. So according to division algorithm we know, according to division algorithm, P of x is equals to G of x into Q of x plus R of x. We will have to substitute all the values of G of x, Q of x and R of x, and we will have to solve the right hand side. And after solving the right hand side, if we get the value same as the values of P of x, then we can say it is verified, else it is not verified. So the value of G of x was minus x squared plus x minus 1. Q of x we have got as x minus 2, and R of x also we have as 3. Now we will have to solve this part. We have to multiply G of x with Q of x. We will have to add R of x in order to get the value of Q of x. So let us multiply minus x squared equals this is minus x cubed minus x squared into plus 2 is plus 2 x squared, and x plus x squared and plus x into minus 2x and minus x then plus 2 and plus 2. So in the right terms this will be minus x cubed plus 2x squared plus x squared is plus 3x squared minus 2x minus x is minus 3x and plus 2 plus 3 is plus 5. We have got the value of P of x as minus x cubed plus 3x squared minus 3x plus 5, and this was actually the value that was given to us in the question as P of x. This is same. Now we can say that the division algorithm has been verified, so we can say hence verified. Now number 1. Find all the zeros of the polynomial 2x to the power 4 minus 3x cubed minus 3x squared plus 6x plus 2. If you know that 2 of its zeros are root 2 and minus 2. This is example 9 from your NCERT textbook that we have taken. In this question, we are given with a polynomial P of x. 2x to the power 4 minus 3x cubed minus 3x squared plus 6x plus 2. And 2 of the zeros are given. That means zeros, as I have told you earlier, zeros of a polynomial means those values of the variable which will make the polynomial to be 0. So 2 are given. But how many zeros are there? That also we have discussed that the highest degree of the variable will give us the number of zeros that we will have for that polynomial. Here the highest degree of the polynomial is 4. That means this polynomial has 4 number of zeros. 4 number of zeros, 2 zeros are given, and we need to find the rest 2 zeros of this polynomial. 2 zeros are given to us as root 2 and minus root 2. These are the 2 zeros that are given to us. That means these are the 2 values for x where the polynomial becomes 0. That is, we can say x is equals to 2 and x is equals to minus root 2. These are the two values of x, two zeros of the polynomial. Now let me tell you, according to division algorithm, that p of x is g of x into q of x plus r of x. That means if p of x is divided by g of x, we get some quotient q of x and then remainder r of x. This was just a reminder to you that we will be using this in the near part of the question. But before moving on, can we write this one as x minus root 2 is equals to 0 and x plus root 2 is equals to 0. Now since x is equals to root 2, the value of x was the 0 of the polynomial. Now we can say that x minus root 2 is a factor of the polynomial p of x and x plus root 2 is also the factor of the polynomial. If we combine both these two, x minus root 2 into x plus root 2 is equal to 0. Then also we can say that now this whole is a factor of p of x. Then if we multiply this becomes x square minus 2 is equal to 0. And we can say x square minus 2 is a factor of p of x that has been derived from the two zeros that was given to us. X is equal to root 2 and x is equal to minus root 2. This can be solved in different method also, but let us first solve out this way, and then if we get time, we'll solve out another way also. Now, if this is a factor of p of x, that it means if p of x is divided by x square minus 2, we get some quotient, but the remainder will be 0 as this is a factor of p of x. We have learned in class 9 regarding factorial that if p of x is divided by g of x and we get some quotient and if remainder is 0, then we say that this is a factor of this. But now, here it is previously mentioned that x square minus 2 is a factor of p of x. That means the division process, the remainder will be 0. So let us divide this. We can consider this one as g of x also. So let us write it for your convenience. That is g of x is equals to x square minus 2 is the factor. And let us divide it, and we should get the remainder to be 0. 2x to the power 4 minus 3x cubed minus 3x squared plus 6x plus 2, and it is to be divided by x squared minus 2. As I have told you in the division in the last two questions, concentrate on the first term, divide the first term of the dividend by the first term of the divisor, and the answer that we will be getting will be my first term or quotient. So this is somewhere here it is. We will be writing it down for our use. First divided 2x to the power 4 by x squared, and you get 2x squared. So your first term for the quotient is 2x squared multiplied with each term of the divisor, you get this one as 2x to the power 4, and 2x squared into minus 2 is minus 4x squared. So just write below the x squared part. Subtracting, the sign changes, and this is cancelled. Highest degree is minus 3x cubed, and minus 3x squared plus 4x squared is plus x squared plus 6x plus 2. And in the process, because the degree is 3 now, it is greater than the degree of the divisor, we will have to continue the division. So divide the first term, again by the first term of the divisor to get the next term for quotient. So minus 3x cubed divided by x squared is minus 3x. So next term in the quotient is minus 3x. Multiply this minus 3x to each term of the divisor. Minus 3x into x squared is minus 3x cubed, and minus 3x into minus 2 is plus 6x. This is minus. So subtracting this cancels. Minus 0 of x squared. This is minus 2. This also cancels. Then dividing again the degree of x is equal to the degree of the divisor, so the division will continue. And the next term is 1 for the quotient, taking as plus 1. So plus 1 into x squared is x squared, and plus 1 into minus 2 is minus 2. This is minus, plus, and this cancels, and then division becomes 0. Now, as soon as the division is over, we get a quotient. And that quotient is 2x squared minus 3x plus 1. We had a divisor, x squared minus 2. So according to the division algorithm, P of x is equals to g of x into q of x plus r of x. Substituting all the values, g of x we had x squared minus 2, q of x we had got 2x squared minus 3x plus 1, and since the numerator is 0, plus 0 is not required. We have x squared minus 2 from the two zeros of the polynomial that were given to us in the question. That means the rest of the zeros can be obtained by q of x, and this could be solved by splitting the term. Now, if we factorize this one, this is x minus root 2 into x plus root 2. And solving this by splitting middle term method, this is 2x squared minus 2x minus x plus 1. Continuing x minus root 2, x plus root 2, and here this is x minus 1 and minus 1 into x minus 1. So we get all the factors as x minus root 2, x plus root 2, 2x minus 1, and x minus 1. These are all the four factors that are possible for the given polynomial P of x. From the four factors, we get all the zeros of the polynomial. Since we have four factors, so we will have 4 zeros, as which was known to us previously when we had the degree of x is 4, so we will have 4 zeros, 2 of which were given, and 2 we have to find out. Considering this part, either this is 0, or this is 0, or this is 0, or this is 0, for the polynomial to be 0, to obtain the value of x, that would be the 0 of the polynomial, that would make the polynomial to be 0, we will have to consider each one the one to be 0, so that we can get different values of x. If this is 0, we get x is equals to root 2. If this is 0, we get x is equals to minus root 2. If this is equals to 0, we get x is equals to 1 by 2. And if this is equals to 0, we get x is equals to plus 1. That means root 2 minus root 2, 1 by 2, and 1 are the zeros of the given polynomial P of x. Hence, we have got all the 4 zeros of the polynomial P of x.